Assalamu alaikum.
Alaikum salam.
So today we will finish lecture 4. Later this afternoon, I'm offering a tutorial class on 3 and 4. So we're going to do a few exercises on lecture 3 and 4. Attendance is optional, as I said, so it's up to you. Then after that, we're going to open the assignment 2. So assignment 2 will be on D2L later today as well. So what we did in lesson 3 is mesh analysis. What we did in lesson 4 is nodal analysis. So both analysis, one to find the voltage at the nodes, one to find the current in meshes or in loops. So just the nodal analysis, just quick thing to review. So if we have this circuit, just say we
Sir?
have, yes.
The class today at 3:30, it will be a tutorial for a lab or for what?
No, for the lab, we're going to do the question today, but will be exercises on lecture 3 or 4.
Okay. Thank
3
you,
and
sir.
4, both together, yes. So, so this is, for example, a circuit. When we do nodal analysis, let's say this is 1 ohm, this is 2 ohm, this is 3 ohm, this is 4 ohm, this is 5 ohm, and this is 6 volt, and this is 10 volt, let's say. So when we do nodal analysis, we say the one node is a reference. So this node is a reference here. Okay. Say this is my reference. Everything connected to it will have the same voltage. So the voltage is going to be 1 voltage here. So this is one node, V equal to 0, my reference. Then I have a node here. Everything connected to it will have the same voltage from this side. So I say V1. Then I have one here, V2. Then we're going to find the equation. We assume the currents are leaving, so the equation here will be 0. I'm going to assume all leaving. So the current in this direction, okay, V1 minus 10 divided by 1 ohm plus V1 minus 0 divided by 2 ohm plus V1 minus V2 divided by the 3 ohm. So this is the third current here. So this is one equation at the first node. Now the second node, I can assume the same thing. Currents are leaving because I don't know the currents. So here the current, this one is V2 minus 6 divided by 5. So it's 0 equal to, because there is no current coming or the currents are leaving. This is the first current, V2 minus 6 divided by 5. This is the first current, voltage divided by the resistance. The second current is V2 minus 0 divided by 4. This is the current in the 4 ohm. The third current will be V2 minus V1 now, assuming it's leaving V2 divided by 3. Those two equations, you solve them, you find the V1 and V2, and those are the nodal voltages. Is this okay? Just a review of what we did last time.
Yes, sir.
So now what we're going to have today, there is a special case where this is not a resistance. Oops. So I'll keep that resistance. But here it's not a resistance between the two nodes there is a source, a voltage source. Now if it's a current source, it's easy because it will tell me the current, no problem. But if the voltage source, let's say this is 4 volt, or let me just put 8, so different number than all the other numbers. Now when you do the currents, this is leaving, so you have, this is still okay, this is still okay, but this is now is a problem. I don't have resistance here, so I can't use this. And the same here, it's a problem. Because if someone says find the current through this voltage source, you can't tell. You can't tell. So I1 is okay, I2 is okay, but I3 I cannot tell. So this is a special case. Now if this was a current source, say 8 ampere, then it's really easy. This current will be 8 because it's leaving here, it's still leaving. This one will be actually at this side 8, not here, will be here because it's gonna go to the node 2. Is this okay if it's a current source? You guys know that if it's a current source, then I don't need to put anything here, just the current value. But if it's a voltage source, it's an issue because I don't know the current. So if we go back, it's a voltage source, then we have a problem. So there is a special case. When we have voltage source between two nodes, we use what we call supernode. So what's a supernode now? So if we have a voltage source between two nodes, we use supernode. If we have a current source between two meshes, you remember last mesh analysis, we use supermesh. Now this is a supernode. The reason that this term, this current cannot be found. So what do we do? This is going to be different now. خلاص كل شيء. Everything here is going to be different. The equations are not going to be like that. We're going to have a supernode equation. So what is a supernode? A supernode, first thing, you're going to relate V1 and V2, those two nodes, with this source. So the 8 volt equal to, see this 8 volt, the 8 volt here, the positive from this side, negative from this side. So it is V1 minus V2. And this is the first equation. So the voltage across this battery or source, the voltage across this battery or this source is actually the positive minus the negative, the difference between this point and this point. So it's V1 minus V2. So this is one equation. The second equation, because I have two nodes here, so I need the second equation. The second equation will be a supernode. What's a supernode? I'm going to actually shade all this. Different color. Which color should I use? Maybe this. So all this will be one node. These two nodes will be one node. And now when it's one node, I'm going to forget about the currents in between, just the leaving currents. I'm going to assume this current is leaving, this is leaving, this is leaving, this is leaving. This is one big node here. So the equation will be this current leaving, so it's V1 minus 10 divided by 1 ohm. Oh, by the way, no current is coming, so 0. Then this is the second current here in this branch, plus V1 minus 0 divided by 2. Then I go to this side here, V2 minus 6 divided by 5. So this is this current going this way. Then plus this current here, V2 minus 0 divided by 4. So the two equations are the mesh, or the supernode equation, the source equation, the voltage across the source is actually the difference between the voltages at the nodes. The second equation, what we call the supernode, this is the supernode equation. So both nodes, we consider them as one node, nothing in between. And we find this equation. Now we have two equations. We solve those two equations. We can find the two voltages, two node voltages. Is this okay? Any questions here? Okay, so we will go to the lecture. Okay, I'm gonna share with you guys the lecture. And one second, something wrong happened. Are you guys able to see the lecture now on the screen? Lesson
Yes.
4. Okay, so we did the exercises until this point. And this is when we have voltage sources between nodes, okay? So it says if you see voltage sources in the network, okay, and this voltage source is actually between two nodes, okay, like this, between this node and this node. And by the way, all this is one node because there's nothing in between. So what do? You're gonna find the equation for the source, which is the positive side minus the negative side. This is the voltage. Then you're gonna assume there is nothing in between the nodes, like it's a short circuit. Okay, and you're gonna have the other equation looking at the currents here. Now the exercise will help. Here's an exercise. Now make sure when you see voltage source between two nodes, you're gonna use the super node here. Okay. So let's look at this question. We're gonna use nodal analysis. So first thing is the reference. This is my reference point. Everything connected to it will have the same voltage. So everything like connected with the wire, not okay. So this is my reference voltage V0. I have two other nodes. This is one and this is two. And there is a voltage source between these two nodes. So once we have a voltage source, that means we're gonna use the super node approach. Okay, we have to use the super node approach. So what is a super node? First thing, equation, the source equation. So the voltage source here between the nodes. It's gonna help me to find one equation. The positive 24 volt here, the difference between V1 and V2 is the voltage here, which is 24. This 24 is basically equal to V1, the positive side, minus V2. This is the first equation. Now the second equation will be the supernode equation. And now the supernode, we're gonna ignore this as it's not there. And we're gonna look at this as one big supernode. How many branches are connected to this one big supernode? 1, 2, 3, 4. So I'm gonna have 4 currents. I'm gonna use Kirchhoff's current law because we're still at the node. It's a big node, yes, but it is still a node. The N current equals to the out currents. Now, how many currents do we know? The current here, we know it, and it's coming to the big node, and it's 2. So there is 2 ampere coming here. It's an N current. The other currents, I don't know. Like this current here, I don't know. This current here, I don't know. This current here. So I'm gonna assume they're all leaving. Okay. And the first one here in the 6 ohm is V1 minus 0. That's the voltage divided by 6. So it's V1 minus 0 divided by 6. The second one, which is in the 4 ohm, it's V2 now. The voltage V2 minus 0. This is the voltage across the resistor divided by the resistance. V2 minus 0 divided by 4. Then the third one, V2 minus 0 divided by 12. The voltage at this side is V2. The voltage at this side is 0. The difference here is the voltage across the resistance divided by the resistance will give me the current. Now I can simplify this equation by multiplying by 12. I'm going to multiply by 12 here just to simplify. So I have 24 equal to, here is 2V1, because when I multiply by 12, 12 divided by 6 is 2. Then this is 3V2 plus V2. So it's 24 equals to 2V1 plus 4V2. This is the second equation. Question here, why don't you include the 10 ohm? I'm not including resistors, I include currents. The current in the 10 ohm, I know it already, 2. So this is the current. I'm doing the sum of the currents, okay? So this is a current. This is a current, and this is a current. Now the current in the 6 ohm resistor is the voltage across it divided by the resistance. The current in the 4 ohm is the same thing. The current is in the 10 ohm is given, it's 2. I know it, so why I should use the resistance now? I know the current already. So I'm using the currents here. Those are currents, okay? Voltage divided by resistance is a current. But if I know the value of the current, then I don't need to use Ohm's law. I know I already know the current. Now these are the 2 equations. I'm gonna solve them. So the first equation here is, so you find the 2 equations. This is first, then we're gonna solve them. Is finding the equation okay now using the super node here because I have voltage source between 2 nodes? Is finding
Yes, sir.
okay. So the 2 equations, (24) equals V1 minus V2, and here 24 equals to 2V1 plus 4V2. You can do substitution as well or elimination. I'm gonna do elimination, so I'm gonna multiply by 4, then add. So when I multiply by 4, this is 96. This is 4 and this is 4. Then I'm going to add. This is 120. This is 6 V1, and this one here is 0. So V1 equals to 120 divided by 6, that's 20 volt. If you substitute in one of the equations to find, so I'm going to substitute into 1, 24 equals to 20 minus V2. So from here, V2 goes to the other side, it's minus 4 volt. I found the two voltages here. Okay. Now, once I find the two voltages, I don't, خلاص, I forget about my analysis. Okay. And I just write that the voltage here is 20 volt. This is V1. And the voltage here is V2, which is minus 4 volt. Says find the voltage across each element of the network. So what is the voltage across the 4 ohm? It's from this side it's 0, from that side is -4. So V cross the 4 ohm equals to voltage cross the 12 ohm. It's the same, they're in parallel. And it is 4 volt. But the polarity is like this. This is positive, this is negative, because 0 is more than the -4. So the positive is actually here, the negative is actually here. Because 0 is more than the -4. Now, V cross the 6 ohm equal to 2, this. Now, 20 here and 0 here, so the positive is here, the negative is here, and it is 20, because 20 minus 0, 20 minus 0. And that is positive up and negative down volt. This is just to show you the polarity. You don't have to write it. Once you say it's 4 volt, that's okay. And the 10 ohm, I know the voltage at this side is 20, but I don't know the voltage here. So this is, I can't find it from that, so I find it from the current. In the 4, in the 10 ohm is actually, I can find it using ohms, because I know the current here, ohms law 2. So 2 times 20, so I times R, 2 times 20, so it is, 2 times 10, sorry. So it's 20. So the voltage here is going to be positive here, negative here, 20. Now, what is the voltage at this point across this source? So the voltage across the 2 ampere source. What is the voltage at this point? It's 20 here, 20 here. There is a 20 here. So you add them, because you go from 20, negative, positive, you add, so it's 40 volt. So this, the voltage here is actually 40 volt. Sometimes the nodal analysis, the technique up to here, is easier than the basic fundamental one, which is if you know the voltage at the nodes and you know the currents, can you find the voltage across each element? This is how you find it. Any questions here? Any questions? Okay, so I'll just move on. You can copy the screen. Okay, so now what we have left is just 2 or 3 exercises. We're gonna do them. This is an exercise. Now this looks exactly like your lab exercise. The question in the lab is like this. So try to do this, and I'll give you a minute or two so you can start this. This is similar to the lab exercise. The lab, I don't know even what lab is this, 4, I think. Try to do this while I'm gonna take the attendance. Oops. So I'll do the attendance. I'm gonna call the names, please, if you're around. Either write something in the chat or say yes. Okay, Abdullah Khalid.
Yes, sir.
Okay, thank you. Muhammad Mohsen. Muhammad Mohsen Abdul Rahman. No. Hassan Abu Hassan. Hassan. No. Rand.
Yes.
Thank you. Yazan. Yazan, no. Sarah. Thank you, Sarah. Abdullah Ali. Abdullah Ali, are you around? No. Maryam Ahmed.
I'm here, mister.
Thank you. Abdullah Ahmed.
Yes, sir.
Thank you. Ahmed Al-Tayyib. Ahmed, you're here or not? No. Khalid Ali. Asma.
Yes.
Thank you. Muhammad Yusuf.
Yes.
Thank you. Leen. Thank you. Fahad.
Yes, sir.
Thank you. Amal.
Yes.
Thanks. Abdullah Hassan. Abdullah. Hazem.
Yes.
Thank you. Samar.
Yes, sir.
Thank you. Ziyad Ali.
Yes.
Thank you. Awatif.
Yes, sir.
Thank you. Isam Makki.
Yes, sir.
Thank you. Manal.
Yes, sir.
Thank you. Hamad.
Yes, sir.
Thank you. Asia. Thank you. Sharif. Thank you. And Ahmed Ayman Taha. Thank you. Okay. Go back
Sir?
to the... Yes.
Sir?
Yes.
Did you call my name, Hassan?
Hassan Abu Hassan.
Yes, sir.
I did, Hassan. Okay, no problem. We can fix that. So where is Hassan? Okay, no problem.
Thank you,
That's
sir.
fixed. Okay, go back. We'll go back to the exercises. We got 20 minutes. I think we can finish. So this is similar to the lab, so try to be able to do this. So we're going to use nodal analysis to find a few things in the circuit. So nodal analysis, it means the first thing we're going to do, we're going to actually find how many nodes we have. We have 2. One of them is going to be reference. This one is going to be my reference. So I'm going to say this is the 0 voltage. Okay. Now it doesn't have to be 0, but it is compared to the other values. I consider it my reference. And this is my voltage here. I can call it V1, Vn, or whatever. Now, since it's one node, I'm going to just say it's one node Vn. Then I'm going to find the equation. I don't know the currents leaving or coming, so I'm going to assume they're leaving. So the sum of the currents equal to 0. The entering current is 0. Leaving currents, I have 3. So I'm going to have 3 Ohm's law. I'm going to find voltage divided by the resistance. So this is 12. This is 5, and this is 2. And the voltage now across this one, it's leaving Vn minus 12. And here Vn minus 0. And the last one is Vn minus 9. So I assume they're all leaving. So Vn minus the voltage here gives me the voltage across the resistor. Vn minus 0 gives me the voltage across the 5 ohm resistance.
Sir,
Yes.
and the equation, you said, yeah, here.
Oh, yes, I saw that. I was, once you said something, I was like, he saw some mistake. Let me look. Thank you.
Yeah,
Okay.
thank you.
Now we're going to simplify this the way you want, solve it the way you want. I'm going to just multiply by 10 here because it's the least common multiple. So 0 times 10 is 0. Then when I multiply by 10 here, cancels out the fraction. So Vn minus 12. Then here it's going to be 2 Vn. And here's going to be 5 Vn minus 45. So I multiplied by 5 here, 2 here, 1 here, because when I multiply by 10, 10 divided by 10 is 1, 10 divided by 5 is 2, 10 divided by 2 is 5. Vn, 2 Vn, and that is 8 Vn. And these two together gives me the minus 57 equal to 0. So from here, Vn will equal to 57 divided by 8, which is in this case 7 point, I think 125 if I'm not wrong, because 1 over 8 is that volt. This is the nodal analysis. So the voltage here is 8.175. Now what will happen if we want to find the current here or any voltage? So if you want to find the voltage, for example, cross R1, it's 12 minus that. Okay, depends on, because in the lab, for example, we'll say find the voltage V1 here. So you're going to be 12 minus 8 point something. This is the voltage once you find Vn. But here we only have to find Ix, which is going to be the current in the 5 ohm. So it is VR3 divided by R3, because it's the current going through this resistance. So VR3 is Vn minus 0 divided by 5, which is basically this current. So it is 7.125 divided by minus 0 divided by 5. And that gives me Ix equals to 1.412. Is that 12 divided by, is it 2.5? I think it might be 2.5.
Yes.
There. So this is the lab question. So when you do the calculation in the lab, you're gonna do it the same way you do here. Exactly, the equation is gonna be the same, just different numbers. You're gonna solve the equation. Sometimes it's easy to multiply by the least common multiple. Sometimes you have to simplify it in another way. So I'll give you a minute so you can copy this. We do still have 2 exercises. So we do them in 5 minutes and 5 minutes. Any questions here? So we'll continue. Here says write the nodal equations only. Okay. So usually when we have something complicated and long, I'm not going to ask you to solve the equations. That's pure math, but just to write the nodal equations. So here we're going to write the nodal equations. So we have 2 nodes. This is a node, and this is another node. You can say this is the node, but everything connected to it is the same thing. So it's one node, and this is the ground. So here we're gonna, when it says write the nodal equations, we're going to write 2 equations. Okay, 2 equations. But what are those 2 equations? Now look at what is between the 2 nodes. It's a voltage source. So we're gonna use the super node. Okay, so this as an indication that super node has to be applied, because you have a voltage source, no current source, voltage source between the 2 nodes. So the first equation will be E1, the voltage source, equal to the positive side, which is V2, minus the negative side, which is V1. This is one equation. You got 50% of the question here. Now the second equation, when you want to find it, you're gonna use not 2 nodes, a big super node. Like this is one node. Okay, this is now one big node. Or you can even say bigger, like this. Now, how many branches are connected to that node? 4. 2 currents I know, and 2 I don't know. So the ones I don't know, I'm gonna assume they're leaving. 4 branches, 4 currents. So the coming currents equals to the leaving currents. This is the super node here. I'm gonna use the super node. So I1 is coming. Okay, I'm gonna write the equation as well, just so I don't get confused. Coming currents to the node is I1. Leaving current, I2 is leaving. Here's the current here. Those currents are values, so usually they're given as numbers. Now there are no numbers here, just write the equations. And then in the impedance Z1, the current is leaving. The impedance Z2, the current is leaving. So Ohm's law, voltage here is V1 minus 0 plus V2 minus 0. This is the voltage across the second impedance divided by the second impedance. Now, do you need to simplify it? Not really. I1 equal to I2 plus V1 over Z1 plus V2 over Z2, and this is the second equation, and we answered the question. Questions just says write the nodal equations. Those are the nodal equations in this circuit. Again, you can copy the screenshot, or you can say it's easy, so we'll just keep going. Okay, so the last one, I think. Again, it says only write the nodal equations, so you don't have to solve them. So here, this is the reference. Everything connected to it will have the same voltage. Oops. So this is V0. Then I have two nodes, one here. So this is one thing, all. There are three branches connected to this node, V1. And then here, V2. Now I don't have the super node thing because between the nodes, I don't have the voltage source. So just normally two nodes. So node 1, the sum of the coming currents equals to the leaving currents. So the coming currents, I have one current coming, which is 3 angle 0. So that branch. Then the leaving currents, I have two. One of them is in the 4 ohm and one of them in the 5 ohm inductance or inductor. So it's V1 minus 0 divided by 4. This is the current going in the 4 ohm. I'm assuming it is leaving. And here is leaving as well. So it is 5-1 minus V1, sorry, why 5-1? It's V1 minus V2 divided by, what is the impedance here? It's J5 ohm. So this is one equation. Now if we do the second node, I have current leaving, and I'm going to assume these two are leaving as well. Okay. When I do the assumption, I forget about my assumptions in the first node. I don't have to look at the first node. Now I'm working on the second node. So no current is coming. Currents are only leaving. One of them is 5 angle 30. It's given in this branch. The other two branches, I have to find the currents using Ohm's law. So the one going here is V2 minus 0, the voltage at one side and the other side, the difference, divided by minus J2. And here it's V2 minus V1 divided by J5. And this is the second equation. Two nodes, two equations. I answered the question. It says just write the nodal equations. So if the question says write the nodal equations, you don't have to solve the equations, because in some tests before, students would spend a lot of time solving those equations, and there is no need. You're not actually getting any extra point. Any questions? No questions, then we're good. Remember, 3:30 today, optional. The assignment should be on D2L soon, okay? and try to do the assignment as soon as it's open, because if you have questions, you need to actually contact me, and not the last minute. If you leave it till the last day, maybe the last day I'll be busy, I cannot help you. Yalla, enjoy your day, and assalamu alaikum. If you have no questions, then that's it. The assignment is on lesson 3 and 4. So mesh analysis and nodal analysis.